Section 2.5 Further applications of white triangles. Bearing. There are two methods of expressing bearing. So look at the first method. When a single angle is given, such as 164 degrees, it is understood that the bearing is measured in a clockwise direction from due north. Every time when you guys see the angle here, it can be go for like 360 degrees. So they're gonna start it with the north and go clockwise direction. This one, that will be 32 degrees. So you're gonna start counting from the north to here, 32 degrees. So 164 degrees more than 90. So that will be on this quadrant 4 here. Okay, it's gonna be going clockwise. Example 1. Let's do it together. First, we try to draw the figure here. Weather station A and B are on an east-west line. So we have a east and west lines here. So I'm gonna call this as a A, and this is gonna be the B. 3.7 kilometer apart. So you know AB will be equal to 3.7 kilometer. Station A detects a pan at C on a bearing of 61 degrees. So what you're gonna do, you're gonna draw the compass here. And then they say bearing of 61 degrees. So starting from the north, you go about like 61 degrees clockwise. Okay, then you're gonna draw the line like here. And then we're gonna call this is gonna be the point C. Okay, so you know this is gonna be 61 degrees. Okay, I'm gonna extend the line here. Station B simultaneously detects the sampling on a bearing of 331 degrees. So in the B here, go draw the compass. So 331, so starting from the north, clockwise more than 270, somewhere like here. Okay, then I'm gonna join the line together. And then the purple color here, that's talking about 331 degrees. Okay, the big angle here. Find the distance from A to C. So we just label it the side opposite to the angle B. We're gonna call B here. This is what we're looking for. Okay, and then I will draw the straight line here, the vertical line here. And then remember the angle, you guys learned it from session 1.2. Okay, you could see I have the Z here. Okay, you could see the Z here. So you know this angle, that will be 61 degrees. Okay, I may just give this D here. So I'm gonna write it down. Angle ACD will be equal to 61 degrees. The reason will be alternate interior angles. Okay, what are the reason? Also, you know this is a 331 degree here. So I will do 360 minus 331. That will be 29 degrees. So this is gonna be 29 degrees. Same idea. Okay, you do the Z here. So you know angle BCD will be equal to 29 degrees. Same reason, alternate interior angle. Okay, so this is gonna be 29 degrees. Okay, now what is the angle ACB? Angle ACB, that will be equal to 61 plus 29. That will be 90 degrees. Ooh. So this is gonna be the 90 degree. Okay, so this is gonna be the white triangle. Okay, so we could look at it. We do have the triangle looks like this. This is a 90 degree. You know this is a 3.7. This is an angle A. This is gonna be angle B. Okay, so since this is a 90 degree, okay, so we could also say angle CAB, talking about this angle, CAB. That would be equal to 90 minus 61, which is going to be 29 degree again. So this is going to be 29 degree. Okay, so we are looking for the distance from A to C. So this is what we're looking for. Okay, y triangle. So we could calculate it. We'll be using cosine. Cosine 29 degree, talking about this angle that will be adjacent over hypotenuse. So B equal to 3.7 cosine 29. Okay, use your calculator. Okay, we have this picture here. And then cosine 29 degree equal to B over 3.7. You should get 3.2 kilometer. And it makes sense, right? The longest side, the hypotenuse is 3.7. And then this side, that will be about 3.2. Caution, a correctly labeled sketch is crucial when solving bearings application. Some of the necessary information is often not directly stated in the problem and can be determined only from the sketch. Just like my picture, after you sketch out, then you could find the rest of the angles. Bearing. The second method for expressing the bearing starts with a north-south line. Okay, only look at this line, north and south. And use an acute angle. Acute angle means less than 90 degrees to show the direction, either east or west from this line. So we always start with either north or south. Okay, north to the east or north to the west, or south to the east or south to the west. For example, north 42 degree east. Okay, north here. And then you want to go to the east, go to this way, and 42 degree. South 31 degree east. Okay, starting with the south and go to the east again with 31 degree. Okay, keep in mind this method for the angle is always acute angle, less than 90 degree. Okay, example 2. Let's try to do it together. First, draw the picture. Okay, let's do this together. A ship lifts ports and sails on a bearing of north 47 degree east for 3.5 hours. So we have the ship A here. Okay, let's start with this one. And then I will draw the compass here. So the sail is going to be north 47 degree east. So going like half here. And then we're going to draw the line. So this is gonna be 47 degree for 3.5 hours. Okay, 3.5 hours. I'm gonna put it here. This part is gonna be 3.5 hours. It then turns and sails on a bearing of south 43 degree east for 4 hours. Okay, and then I'm gonna use here. I'm gonna draw the compass again, and this time it's gonna be south 43 degree east. So starting from here, somewhere like here. Okay, so gonna draw another one. this time it's going to be longer. So somewhere like here. Okay, and I'll call this is going to be the B, and this point is going to be the C. And the angle here will be 43 degrees. And also they use 4 hours. So this time is going to be 4 hours, the longer. If the ship's weight is 22 knots, nautical miles per hour, find the distance that the ship is from the port. So this is what we're looking for here. Okay, and then they say the weight is going to be 22 knots. Okay, so first figure out the angle here. This is a 47. Okay, let me extend the line here, and we call this is going to be the D. Okay, so 47 degree. This one is also 47 degree. So we have angle ACD equal to 47 degree because the alternate interior angles. And then angle ACB, that will be 47 plus 43, which is gonna be 90 degree again. So this is gonna be a 90 degree. So this is gonna be the white triangle. Okay, then the B here. What is this B? What is the A here? The B, the distance of here, they only give you the hours, 3.5 hours, right? But they also give the ship's weight is going to be 22 knots. So the distance, the B, that would be equal to, the weight is 22 knots times 3.5 hours. That will be 77. Nautical miles. Okay, I've just put the 77. And then the A here, do the same thing. The weight is gonna be 22 times 4 hours. So that'll be 88. Same unit, so 88 here. Okay, we are looking for the C, right? The distance here. And then we have the white triangle. Okay, this is a C, B, and this is a 88. This is a 77. What we're looking for is the C. So we could use the Pythagorean theorem. 77 square plus 88 square equal to C square. Okay, use your calculator. We do have a 5,929 plus 7,744. So C square equal to this number. And then use your calculator. Square root of this answer. You should find 116.93. Okay, write down the unit. Okay. Check the work from the PowerPoint. Okay, I will have this picture here. And then we figure out angle C here, that'll be 90 degree. So we could calculate the A and the B. And then use the Pythagorean theorem to calculate the C here. They just rounded up to 120. Okay, and my answer is gonna be 117. Okay. Example 3. The subtense bar method is a method that surveyor used to determine a small distance d between 2 points P and Q. The subtense bar with the length b is centered at the Q and situated perpendicular to the line of sight between P and Q. Angle theta is measured when the distance d can be determined. Find the d. Okay, I need to find the d here with the theta equal to 1 degree, 23 minutes, and 12 seconds. And b will be equal to 2.0000 centimeters. Okay, the b is talking about the whole length here. Okay, you could just divide it by 2. You're gonna cut it half for this triangle. Okay, so we want to find the d. We could consider the half the white triangle here. I'll be using the tangent half of the s angle with tangent theta over 2 equal to opposite, which is going to be b over 2 divided by the d. Okay, the theta will be divided by half. So tangent theta over 2 equal to b over 2 divided by the d here. Okay, we are looking for the d. You know the b, you know the theta, you could just plug it in. And then for the degree, you want to convert it to the decimal space. Remember how to do that? You could do 1 degree plus, use the minute divided by 60. And since we do have the seconds here, so you're going to be divided by 3,600. Use your calculator. You're going to get this guy. Okay, plug it in and use your calculator. You should find this. Okay, example 4. Francisco needs to know the height of the tree. From a given point on the ground, he finds that the angle of elevation to the top of the tree is 36.7 degrees. He then moves back 50 feet. Okay, so he's supposed to standing here and then look at the tree. And then he's gonna go back 50 feet. From the second point, the angle of elevation to the top of the tree is 22.2 degrees. Find the height of the tree to the nearest foot. Okay, we want to find the h here, but we don't know about the length of the AC. Okay, we just let it like x. And then we know AD here, that will be equal to 50 feet. So what we're gonna do, you can see when you look at the white triangle ABC, we do have the h in here. If you look at the triangle DBC, the big triangle here, the BC is also equal to your h. So they share the same opposite. And then we'll be using the tangent, right? Because tangent equal to opposite over adjacent. Same idea for this guy. So first, consider triangle ABC. We have the tangent 36.7 degrees equal to opposite over adjacent. So h over x. So h, this is what we're looking for, equal to x times tangent 36.7. Now, we want to consider the triangle DBC. Do the same thing. Tangent 22.2 equal to opposite, which is going to be the h, over the adjacent. The adjacent, that will be 50 feet past the x here. Okay, simplify it. Now, we do have a two equation, two variables, h and x. And since they do have the h, so we could equal to each other. Now, we're gonna distribute the 50 and the x to the tangent 22.2. And then we're gonna combine the 9 terms, which is gonna be the x together. So we're gonna subtract x tangent 22.2 degree for both sides. And then we do have x here, we do have the x here. We try to factor out the x. When you factor out the x, you're left with this guy. And then we're gonna divide the whole thing for both sides. Okay, since we are looking for the h, not the x, right? So we could substitute the x into here. Okay, just put the whole thing into the x. Now use your calculator. You should get about 45. Okay, so the height of the tree is approximately 45 feet. That's it.